As you might know, CCIE routing and switching exam consists of two separate sections. So we have two sections of the exam. And I do apologize about my handwriting. Unfortunately, you're going to be stuck with it because apparently I have not learned how to write properly in my school. Now, the first section that we have is the dedicated troubleshooting section. And after that is finished, you're going to be faced with the configuration section. Now, the characteristics of the troubleshooting section is that it is a maximum of 2 hours long. In these 2 hours, you will be faced with 10 to 12 tickets, and you need to solve at least 80% of the points assigned to the tickets. Now, usually, this is the official information from Cisco. A little bit less official information from Cisco is that you are actually going to have 10 tickets in your troubleshooting section. Now, these tickets are going to be ranging in point value between 2 and 3 points. Most likely layout of the troubleshooting section is going to be that you're going to have 8 tickets that are 2 points, and you're going to have 2 tickets that are 3 points, giving you the total of 22 points. Now, 80% of 22 is 17.6. Now, if you want to pass the exam, you need to get 17.6 points. Now, this is a little bit difficult because if you take a look at the layout of the points, let's say that you have your 10 tickets, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and let's say that the point value here for the tickets is, let's say 3, 2, 3, 2, 2, 2, 2, 2, 2. In order to pass the exam, if 17.6 is indeed the passing mark, if you don't solve this 3-pointer and this 3-pointer here, you cannot pass the test because you're going to be below the passing mark. The same is true if, for example, you don't solve the 3-pointer and this 2-pointer. You are going to be below 17.6 mark. This is why the actual passing mark for the troubleshooting section is going to be 17 points. So you need to get at least 17 points on the board solved correctly in order to pass the lab. Again, this doesn't really make lab much easier because in this case, if you get a 3-pointer and a 3-pointer that you missed, you will be passing the lab. But if you miss 2 3-pointers, you are in trouble because with 2 3-pointers, you are below the passing mark for the troubleshooting section. So the statistics are not on your side. You have to solve at least one of the 3-pointers. Now, thinking about it, what do you think is the difference between the 2-pointers and the 3-pointers in the lab? Is it the level of difficulty or is it perhaps something else? I am seeing the answers being typed, so let's take a look at those answers. Jim says it's number of changes. Well, number of changes, or let's say, I like to word it a little bit differently. It's the number of faults. So for 2-pointers, Cisco says it is going to be a single fault that you will be dealing with. Now, for 3-pointers, Cisco says it will be 2 or more faults. Now, the definition of fault is somewhat vague. What could the fault be? Well, in one case, a single fault could be just, let's say, a mismatched password on one router. In some cases, it could be a mismatched password or password authentication on multiple routers, but it's still considered to be a single fault. Now, when we talk about 2 or more faults, that means that whatever was written in the ticket, whatever is the technology that is having challenges, whatever the problem is, there is more than one thing, related or unrelated, that is preventing this from working. Now, it could be something along the lines of, let's say, you have a couple of routers connected to the VLAN, to the switch, and somehow switch or the VLAN assignments there are misconfigured. But then on top of that, those routers are supposed to be running, let's say, EIGRP, and then EIGRP is misconfigured, which in turn prevents, let's say, hosts 1 and 2 from communicating with each other. So this would be an example of, for example, a 3-pointer ticket. Now, please don't fall for the trap thinking that 2 pointers will be easier than 3 pointers. That may or may not be true. Now, usually this is the point where I'm going to give you an example, so give me just 1 minute to prepare for the example. I'm going to stop the video for that, and I'm going to come back with an example. I'm going to give you an example of a 2-pointer ticket that, in my opinion, on a level of difficulty from 1 to 10, is somewhere around 15. We're going to go through this one example where I'm going to show you a 2-point ticket that, in my opinion, is rather difficult. So here is the topology. Now, the topology here consists of 4 routers. We have R1, R2, R3, and R4. As you can see on the diagram, R1, R2, and R3 are running OSPF in area 0, and R4 is somehow outside of this domain. So I'm going to go here to my terminal, and I'm going to connect to router 1, going to connect to router 2, going to connect to router 3, and router 4. And the goal of this task is very simple. What we want to do is we want the loopback of R1 to be able to ping the loopback of R4. In other words, we want the communication between this loopback and this loopback here. So let's go on R1 and take a look at what's going on. So if I go to R1 and if I do show IP route, I'm going to see that I actually do have the route for my loopback in the routing table. If I try to ping this loopback, I'm getting destination unreachable. So you can see here that I'm getting .u.u.u. Okay, fair enough. Can R4 reach R1? So I'm going to go to R4, and if I do show IP route, I now see how R4 is connected to the rest of the network. I can see here that we have the gateway of last resort set, which means that we do have the default route. We can see that this route here is a static route, so this is how R4 gets back. So if I try to ping R1, when I try to ping, I'm getting just a dot. So I'm not even getting unreachables at this point. So moving onwards with our looking at what the problem could be, if I go to R2 and if I do show IP route, I can see here in R2's routing table, well, actually, I don't see it, but there is no route for R4's loopback. On R1, I have it in the routing table. On R2, I don't have it in the routing table. If I go to R3, and if I do show IP route, I can see that I do have the route in the routing table. It's a static route. And from R3, if I try to ping R4, it seems to be working. So a natural assumption here would be to think, is R3 that has a static route to R4? And I mean, it's logical. Here we have R3. It has a static route to reach R4's loopback because R4 is obviously not running OSPF, and R4 has the default route back. So we do have some reachability there. So it's a natural assumption to think, okay, is R3 actually redistributing this route into OSPF? So if I take a look at show run and router OSPF, I can see that I am redistributing static routes. So why is it then not showing up on R2 in routing table? But it is right here in R1's routing table. Any thoughts? Anyone has an idea what the problem could be here? If you do have an idea, write it in chat. Filter list on R2. Okay, that's very good. Now, filter lists would be configured in an OSPF process. So here is the OSPF process. It doesn't have any filter lists configured. And if I do show run include access list, I'm getting nothing. If I do show run include prefix lists, I'm getting nothing. If I do for route maps or policy maps, anything that can remotely do any filtering on R2, nothing's there. The tunnel, okay. There are no tunnel interfaces configured because we would see them somewhere in the routing table, and here we can see that there are no tunnels. It's all serial interfaces, at least on R1. On R2, again, we are seeing just the serial interfaces and the loopback, so there is really nothing of the sort. Now, one thing that I noticed there is a comment that says LSA is propagated to R1, R2 is filtering the route from its own routing table. Very, very good. So LSA has made it all the way to R1, and here it is in the routing table of R1. But what could be preventing this LSA from going into the routing table of R2? This is, as I said, very, very challenging problem. It's going to go very deep. And at this point, I don't expect you to actually be able to solve it. This is more of a warm-up exercise to, you know, get the brain going. So let's see how far you actually get with it. If you want me to run some command or if you want me to show you something, please let me know. If not, I'm going to show you what the problem is. Or I'm going to continue troubleshooting it until we fix it, even though I'll have to pretend that I don't know what the problem is. But I will follow the steps of what I think is good troubleshooting, which is, incidentally, something that I will be talking about next. What is configured for OSPF on R2? Well, as you can see, it's basically just the network statement, nothing more than a network statement. What is configured on R3? So let's take a look at that. Well, as you can see, it's router OSPF, 2 network statements, and redistribute static subnets to get that one static route into the OSPF. Some type of a null route problem. Well, if it was some kind of a null route problem, we would be seeing a null route somewhere in our routing tables. And here is the routing table of R3. And again, as I say, the only interfaces that we see are serial and Ethernet interfaces. Here on R2, if I take a look at the routing table, only serial and loopback interfaces. And here on R1, pretty much the same problem. So let me troubleshoot this for you. On R1, we have the route in our routing table, and as expected, it is an external OSPF route. On R2, we do not have the route in the routing table. So my initial thinking here would be, okay, let's take a look at the OSPF database. Let's see what the OSPF database is going to tell us about this route. So if I do show IP OSPF database on R2, I am going to see the LSA in the OSPF database. Now, this is something that I expected to see, because how else would R1 get this route if R2 didn't flood this LSA to it? But what is preventing this LSA on R2 from going into the routing table? To answer that question, I actually have to take a look a little bit deeper into this LSA. So if I do show IP OSPF database external, this is the LSA that I'm seeing. And one of the things that should kind of stick out is the forward address. I do have the forward address here, which says 192.168.34.4, which is nothing unusual, because if I take a look at the diagram, this is actually the IP address on R4 here on this link. So it kind of makes sense that this is the forwarding address. But there is a problem with this, because in OSPF, the forward address is not always going to be installed. So here is where this ticket becomes really difficult. The OSPF forward address, and mind you, I will talk about this in much greater detail when I actually talk about OSPF from a technology standpoint. Here we are just looking at the troubleshooting example, as at an example ticket of what you might encounter in the lab, and what would I consider to be a very difficult two-point ticket. So from OSPF's perspective, the theoretical knowledge of OSPF, the forward address is always going to be present in an external LSA in a case of the NSSA area. Now, this is OSPF Area 0. Area 0 is not and cannot be a stub area or the NSSA area. It is always a regular area. Which means, why is then the forward address installed? This is where the difficult part begins. The OSPF forward address will be installed on an external LSA in a non-NSSA area if an outgoing interface for the redistributed external route is enabled for OSPF, the next hop is known by OSPF, and the interface is not passive and is non-broadcast or broadcast network type. Okay, a lot of things to remember, but as I say, I will go about this in detail when we talk about OSPF. So let's take a look at this interface here. This is R3. It's R3 who is actually redistributing the static route into the OSPF. This is an Ethernet interface, which means by default it is broadcast network type. Now we can see here on the diagram that there is this blue thing around this interface, which leads me to assume that OSPF might actually be enabled on that interface. And if I go to R3 and I say show IP OSPF interface is brief, I can see that on Ethernet 00, OSPF is indeed enabled. Now, mind you, we have 0 neighbors on this interface, but that's irrelevant because OSPF is enabled on this interface, and interface is not passive. If I take a look at show run pipe section route through OSPF, I don't see any definition of the passive interface, which means that this interface here is non-passive. Now, by virtue of OSPF being enabled on this interface, if I take a look at the static route that actually injects this route, it says 192.168.34.4, which is part of the subnet that is enabled for OSPF. The next hop of the external route being redistributed is known by OSPF. This tells me that the forward address will actually be installed on this LSA. So this is the reason why R3 installs the forwarding address on this LSA. Okay, now that we have actually understood this, if we go to R2 and take a look at R2, why would this cause R2 not to install this route in the routing table, or this LSA in the routing table, when R1 here, OSPF database external, has the exact same information? And this is one other thing with OSPF, they are in the same area, therefore their databases would be identical. So here on R1, I have the forward address and I do have the route in the routing table, but not on R2. Well, that must mean that something is wrong with the forwarding address on R2 itself. So if I do show IP route this, take a look at this entry here. It says here that route 192.168.34.4/32 is known as a static route. So there appears to be a static route on R2, causing this route to be installed in a routing table. And this will override, let me see, I don't have it in the history. So then this would override this /24 route to reach the same, to reach the forward address. Now, mind you, this does not cause the route or the forward address to be unreachable. I can still ping it. There we go. No problems. This causes OSPF not to trust this route. Now, this is another rule of OSPF. If OSPF router receives an LSA, an external LSA, that has a non-zero forward address, this address, in order to be used, must be known by OSPF. Show IP route 192.168.34.4 on R2 shows us that there is a static route on R2 that makes the forward address reachable. Now, as I said, one of the rules for forwarding address is that in order for this LSA to be used when it has a forward address that is non-zero, is that the forward address is known by OSPF. In our case, forward address is not known by OSPF. In the routing table, it is actually known as the static route. When we have this situation, the OSPF cannot trust that this route is loop-free. Therefore, it cannot use this LSA for routing. So this is what is causing this route not to go in the routing table on R2. That's fine, but how do we fix it? Well, to fix it, we have to go back to this list of things. If this interface is broadcast, the route, the forward address will be installed. But if it's not a broadcast interface or non-broadcast, it will not go in there. So making this interface, for example, point-to-point, will solve the problem. So would be this turning off OSPF on the interface, so would making it passive. Well, next hop known by OSPF is not something that we can actually change, because that would actually involve changing or removing the static route for 4444 on R3. There is another solution, and that is taking this static route that we have on R2 and actually removing it from the routing table. Now, one of the big things that I have with many of my students going to the CCIE lab is that they think that this would be a valid solution. Oh, let's just remove the static route and be done with it. Or an alternative solution is, oh, okay, so this static route is causing me the problem. Let me change the admin distance on it to be 255, effectively removing it from the routing table. Every time when you have this solution in mind, oh, let me remove something, let me make something disappear, you are probably on the wrong track as far as the exam goes. Because in the exam, you need to correct the underlying issues without removing any of the configured features. Now, one of the configured features in this situation is the static route on R2 that is causing our problem. So we cannot remove that. What can we remove? Well, if we take a look at our diagram here, our R4 is not running OSPF. So anything that we change on this interface on R3 is not going to make any difference from the perspective of R4. So even though OSPF is turned on, even though the interface is actually broadcast, any of these changes would make no difference on R4 because they will not alter behavior in any way as far as R4 is concerned. So these features might be enabled, but they are not actually operational. The OSPF configured on this interface from R3's perspective is just sending hellos. So one of the correct solutions that we can implement here is to actually go to R3, say router OSPF1, and say passive interface Ethernet 00. Now, if I go back to R2, and if I take a look at the database, now I will see that the forward address is installed in the routing, that the forward address is not present on the LSA, which means that on R2, 4440, 4444, sorry, /32, I thought it was a /24 route, is now in the routing table. If I do show IP route, I can see it here. So this is an example of a difficult ticket. Why is this difficult ticket? Why do I consider this to be a difficult ticket? Well, I consider it to be a difficult ticket because it requires this deep understanding and the deep knowledge of OSPF to solve. You cannot just stumble upon this solution. You actually have to know what's happening in order to figure out what the problem is.